Good evening, YouTube. Needlebender785 Ohio with another video. This is kind of getting exciting here as we got the RF deck right side up. The bottom has been 100% completed. There are exactly 5 things that are not done here on the upper deck as far as having it 100% ready. But we are at the time where we were doing a tube burn-in, and now we're getting ready to apply some test high voltage. This is again current limited, and right now I have it set to 3 milliamps, so that's extremely low current. And we're going to be doing some high voltage testing. Meters work. We do have a meter that just decided to hook up. This shows since we do have the high potential and the screen is currently grounded, which is it's a grounded screen amplifier, but since it's not in operation, we do not have the actual screen voltage. So the cathode and the screen are at the same potential. So what does that create? That creates a kind of like your strap configuration in this configuration when it's off. So it does need to have a negative, a grid needs to be below the cathode. With that configuration, it's only, I believe, 10 to 12 volts to bring the tube in the cutoff, and this supplies negative 400, which is what that is if the screen was actually live. Now, we can't test the screen operation in this configuration because of the different ground potentials. The screen actually, the B negative coming from the power supply is not referenced to ground. This power supply references its negative to ground, so we can test the tube, and obviously we can't key it up, can't do anything like that, but we can test the actual that the tube is good. So the only thing we're not going to be engaging is the actual screen voltage, which we'll keep that off, and we're going to see our cutoff voltage on our grid because that's going to be operational. So this will actually show, you can demonstrate that the tube will actually start to conduct a little bit. If you don't have that negative screen in reference to the cathode, which this circuit takes care of it. But let's go through the startup sequence here. As you can tell, the amp is plugged in. The high voltage is off. There's really nothing that's on, so we're going to turn on our zero plate volts, zero plate current, and these bottom meters, they indicate that there is no current flowing into or out of either grid or screen. So these are indicating as advertised. And the next thing I'm going to turn on is our filament, and that's going through its step start process. There we go, the filament is on. And we're going to turn on our high voltage, which is all that means we have, that's obviously negative 407 volts in reference to the cathode. And then so we asked for a high voltage, and then we got our high voltage right there, boom. So we got our high voltage, as you can see, 6 kV. We have our high voltage indication, and we have our 6 kV plate voltage right there. As you can see, that's 600 microamps. That's 0.6 of a milliamp, and that is actually the consumption without the tube as well. There's a resistive voltage divider that actually involves in measuring for the sensing circuit, and that consumes that, so that the tube is actually not drawing anything. And this tube is holding really good. Got the cutoff voltage right there. The only issue I've had so far literally is the noise. This fan is extremely loud, and I'm actually still thinking, how am I going to handle I'm going to have to build some kind of an enclosure for this. This is very, very loud. So as you can see, if we shut this off, look at the high voltage light disappears. That means its high voltage is no longer present. There we go. And if we shut this off, we'll see it'll start to bleed down. the tube is in excellent condition. Obviously we haven't tested its operation, but it's holding the high voltage, and it's doing what it's supposed to do. That's because the current is being discharged off the capacitors. And if we turn it on, back to 405, it's reading 0. And you turn it off, you will see some bleed down. So there she is. Now that is one loud box. Like I said earlier, I don't know. I hope my audio came in pretty good. But this box is extremely loud. That is the only issue I've had so far with this box. Okay. We're down to 4.5 volts on the grid, and the box is depowered. Power supply's off, and we can go ahead and unplug all of these fun devices. Okay. We're done with this piece of equipment. Now we're just gonna talk about this box. So far everything was either met or exceeded my expectations as far as the tube, this build, and everything literally worked as advertised. And I actually kind of anticipated a little bit more. So far, every part of the circuit I built performed to spec. And I mean, everything was within 5 or 10 volts. When I'm talking about like your high voltage circuit, my screen was supposed to be 1,000 volts, and I think it's 10, 12. Everything was phenomenal. This is supposed to be negative 412, and it's 407. And again, my line voltage here is a little low, and it's just kind of when you live out in the country and you live at the end of the line, and you're about 10 miles from the nearest substation, your line voltage drops during the middle of the day. And that's why my on my 3cx5000, on a good day, like in the winter time, I'll be resting at 6.2 kV. And on a bad day when everybody's running their air conditioning, I'll be at 5.5. And that's just I guess that's just living out. When you live in the middle of nowhere, that's what you get. This box is kind of going to be the limit of my personal power supply here down in my shop. I have my own sub panel here. It's a 60 amp sub panel, which can supply 60 amps, which is what this box is going to require. But not planning on running it super hard. I just want to have it running really clean, kind of cruising, probably between, I don't know, I want to cruise around 10K PEP. That's my goal. Obviously, it should be able to do more, but I want to cruise at 10K. And super excited. The progress today, like I said, installed this. This is a grid control power supply. This is the bias keying relay. This is the output relay. And this is obviously not hooked up at the moment. This is basically your pass-through. And it goes right out to this. I got that part hooked up. So the only three things that need to be done. I already have this wall. This is a fake wall right here. This is just so I can build this other wall here. So before anybody makes a comment that my transformers are not secured from the tuning, basically not isolated from the tuning coil, that's actually incorrect. So the reason why I have this fake wall in here and not the one that's actually going in here is because I'm trying to measure exactly the length that I need for the piece of metal that's going to go here. So there's going to be a wall, a metal wall, just like this one, going all the way to the ceiling, and that's going to totally insulate from any RF this power supply. Now this is our filament transformer, and this is our control transformer, and it has its own rectifier for the grid. Here's the fan to cool just the transformer section, and so there's going to be a metal wall that's going to be right here, all the way to from floor to ceiling. What I have done on my real one, this is, like I said, this is the dummy one. The real one has the capacitors in there. I didn't want to take in and out the one with the capacitors. That one has a hole on the bottom, about a 2-inch diameter hole. So the air, the way we're using this air right here from this fan, obviously the air for the tube is kind of confined to cooling the tube only, so you can't really use it for much else. But what we have going on here is we're ingesting air into here. It's going to be in this own compartment, cooling all the transformers, all the heat sinks from the regulated power supply. It's going to go into here, transition through the front, kind of not doing much, and then it's going to pop out right there on the bottom and come up through the tank coil, go through this area, just kind of ventilate and exit right here at the top. So this is going to be our main 4-inch exit for the tube, and there's going to be about our, I would say about an 80 millimeter fan cover for exiting the residual air. And that's going to be, so the box is fully ventilated. Every single compartment in here has some sort of circulation going on. Capacitors, tuners with the coil, they're already done. They're all ready to go. They just need to literally need to be put in and secured. So I just have, like I said, I have this dummy wall just so I can take it in and out, and I don't have to worry about damaging the actual capacitors. And that's the only reason. So that's already done, and it hooks on right here, and it just there's going to be a glitch choke somewhere in here that's going to tie into the tuners. There's going to be RG393 line to this post right here, and this RG316, which is your pass-through / receive, and that's going to tie into this connector right there. This is the keying wire, and it connects to 2 places. So this sends a signal. This connects to here, and this connects to this relay. So there's going to be 2. So literally I have to connect this, and the RG393. And that's it, because everything else already is wired up. Now these meters may need to be, there might need to be a calibration depending how, especially like on the current reading. I 100% calibrated the grid and the screen. I spent a couple of days calibrating it, calibrated the high voltage reading, but the high voltage, well, actually the plate current, it's pretty close, but it might need to be calibrated. There's a metal piece that is missing on the bottom. It kind of needs to restrict the airflow along the wall there, and that needs to be installed. Other than that, this box, there's going to be some modification needed to be done to the actual power supply. Very minor, but minor upgrades and modification. But this box, on the next video, we're going to have the tuners in, and it's going to be a power off test where we're going to be applying, we're going to be tuning to an emulated resistive load. So we can show a pass-through tune, input tune, and our tank coil resonance at the So what we're going to have is from 1500 ohms to 3700 ohms. There needs to be able to tune any load from 3700 ohms to 1500 ohms. That's what the original design talks about. And my normal 3000 coil tunes about 1200 to about 6000. So I know I'll be able to achieve with the exact same design. So stay tuned. This box is getting close to being done. And so far every test I've done was a success. Like I said, some minor calibration on the current meter, but everything else is doing fantastic. Anyway, 73s, and stay tuned for the next one. Needle Bender 785. And here in the Buckeye State, we're back on the side.